Mercury is not what you think it is. For over 50 years since Mariner 10's brief flybys in the 1970s, we convinced ourselves we understood it. A scorched, airless rock, the smallest planet, geologically dead and fully mapped. Then NASA's Messenger spacecraft finally entered orbit in 2011, and what its instruments found shattered that comfortable illusion, piece by piece. Mercury is the closest planet to the Sun, orbiting at an average distance of just 57.9 million kilometers, completing a full year in only 88 Earth days. For decades, that proximity made it one of the hardest places in the solar system to study, since the Sun's gravity makes it extraordinarily difficult for any spacecraft to slow down enough to enter orbit without falling into the star itself. The surface temperature swings between extremes that defy intuition. During the day, surface temperatures reach 430 degrees Celsius, hot enough to melt lead. At night, with no atmosphere to retain heat, temperatures plunge to negative 180 degrees Celsius, among the coldest recorded anywhere in the inner solar system. A planet closest to the Sun, and also one of the coldest places we've ever measured. That contradiction alone should have been the first warning that Mercury wasn't going to behave the way anyone expected. But the most disturbing discovery wasn't on the surface at all. It was hiding in permanent darkness. Mercury's axis is tilted by less than 1 degree, almost perfectly upright relative to its orbit. That means certain craters near its poles never receive direct sunlight, not for a single moment, across the planet's entire 4.5 billion year history. Inside them, temperatures never rise above negative 170 degrees Celsius. In 1991, radar observations from Earth detected unusually bright reflections coming from inside several of these polar craters, a signature that matched one substance almost perfectly: water ice. On the planet closest to the Sun, in craters that never see daylight, ice has been sitting untouched for billions of years. Messenger confirmed it in 2012 using neutron spectrometry, mapping hydrogen concentrations consistent with frozen water trapped beneath dark, carbon-rich material. Scientists estimate the total deposits could range from 100 billion to over 1 trillion metric tons, locked inside craters that have never felt warmth since the solar system formed, delivered by billions of years of comet and asteroid impacts, and frozen in place forever. Then there's the planet's interior, which turned out to be even stranger than the ice. Mercury is small, only slightly larger than our own moon, yet it has an iron core that makes up roughly 85% of its total radius. For comparison, Earth's core makes up only about half of its radius. Mercury is, by proportion, almost entirely made of metal, wrapped in a thin shell of rock barely 400 kilometers thick. No planet in the solar system has a core this disproportionately large, and nobody fully agrees on why. One leading theory suggests Mercury suffered a catastrophic collision early in its history, violent enough to strip away most of its outer rocky layers and leave the dense metallic core exposed beneath a thin remaining crust. Either explanation means the same unsettling thing. Mercury may be the leftover skeleton of something that should have been much bigger, and that massive iron core is still doing something nobody expected. It's generating a magnetic field. Small, rocky planets aren't supposed to maintain active magnetic fields once their cores cool and solidify, and Mercury's core should have cooled completely billions of years ago, given its size. Yet Messenger confirmed Mercury has a real global magnetic field, generated by a core that is at least partially still molten. Some researchers believe sulfur mixed into the core may be acting like an antifreeze, keeping portions of it liquid far longer than pure iron ever could. That magnetic field interacts violently with the solar wind, since Mercury receives the most intense, unfiltered stream of charged particles of any planet. Messenger detected magnetic storms happening on Mercury's dayside, roughly 10 times more frequently than similar events occur at Earth. The planet is being hammered by space weather on a scale nothing else in the solar system experiences. The surface tells a story of violence stretched across billions of years, densely cratered from relentless bombardment with no atmosphere to erase the scars. But it isn't purely dead either. Messenger found smooth volcanic plains covering large portions of the surface, evidence Mercury was geologically active for at least its first billion years. Strange cliff-like structures called lobat scarps, some over 1,000 kilometers long, wind across the surface, formed as the entire planet's interior cooled and contracted, causing the crust to wrinkle and shrink like dried fruit. Mercury has been getting smaller, its diameter shrinking by as much as 7 kilometers over its history, and some scarps appear remarkably young, suggesting the contraction might not be entirely finished. There are also bizarre hollow formations found nowhere else in the solar system, shallow depressions with bright interiors clustered inside crater floors. They appear relatively young, and may be forming right now through the loss of volatile material directly into space, an active transformation of the surface that nobody anticipated on a supposedly dead world. Let's pause here, because I want you to understand the full picture. Mercury isn't simply a barren rock baking next to the sun. It carries billions of tons of water ice in permanent darkness. It hides a core so massive it may be the remnant of planetary-scale violence. It generates a magnetic field that shouldn't exist according to the physics of bodies its size. Its surface is still shrinking, still possibly venting material into space today. There is no simple version of this planet hiding underneath the assumption of dead and boring. And here's the part people overlook. Bepi Colombo, a joint European and Japanese mission, is currently looping through flybys before entering Mercury orbit, carrying instruments more sensitive than anything Messenger carried. It will map the magnetic field in far greater detail and search for answers to questions Messenger could only begin to ask. So, why does any of this matter beyond satisfying curiosity about a small, scorched world? Because Mercury represents an extreme case study in how rocky planets form, cool, and evolve under the harshest possible conditions that may be common on rocky exoplanets discovered orbiting close to other stars throughout the galaxy. Understanding how a planet this small can hold onto a partially molten core, generate a magnetic field, and trap ice in permanent shadow. Despite searing daytime heat gives scientists a working model for evaluating similar worlds we will never visit directly. We will likely never walk on Mercury. The temperature extremes alone make sustained human exploration almost impossibly difficult. We will never casually visit those ice-filled craters near the poles, sitting in cold that has not changed in billions of years, just a short distance from surface temperatures hot enough to melt metal. Here's the sobering reality. Mercury has existed for 4.5 billion years, closest to the sun the entire time, absorbing more radiation and more violence than any other planet in our solar system, and it has never stopped surprising the instruments we send to study it. When you think of Mercury, if you think of it at all, you're probably picturing a small, simple, unremarkable rock. You're not picturing billions of tons of ancient ice. You're not picturing a core so large it dwarfs every other planet's proportions. You're not picturing a magnetic field that physics says shouldn't be there, or a surface that is still actively shrinking today. Mercury isn't ignored because it's boring. It's ignored because nobody bothered to look closely enough for long enough until very recently. I hope this gave you a new perspective on the planet we thought we understood. The solar system is stranger than it appears, and Mercury is the proof. If you enjoyed this video, consider subscribing, and I'll see you next time.